In 2016, Tom was enjoying his vacation with his wife in Egypt. He was a professor at UC San Diego, enjoying a well-earned rest. He didn't know it yet, but this would turn out to be the most dangerous trip of his life. One day he started to feel sick. It all began with a minor stomachache. Initially he thought it was simple food poisoning. It was a common thing for tourists after all. But he was wrong. Within days his condition got far worse. As he was rushed to a local clinic, doctors in Egypt struggled to treat him. Then he was transported to Germany and later to California. At every stop, Tom received the best available medical care. Doctors used frontline antibiotics. They used the heaviest, last resort drugs known to science on him. But the infection didn't even flinch. Eventually it would spread into his bloodstream, causing sepsis, and Tom would slip into a coma. Not long after, the infection was officially classified as pan-drug-resistant, meaning it had developed a resistance to any and all antibiotics available in the world. And now, as Tom was connected to life support, all doctors could do was hope for a miracle. What makes this case even worse is that Tom's condition was not caused by something nature created. It was something that was accidentally engineered by human irresponsibility. The cause of his condition is known as the CRAB, one of the deadliest superbugs known. The CRAB is considered exceptionally dangerous since it is resistant to carbapenems, one of the most powerful class of antibiotics available. That is why this bacterium has a fatality rate of up to 70%, high even among other superbugs. These superbugs have already taken millions of lives and, according to some projections, are estimated to become the leading cause of death by 2050. But to understand how we even got here in the first place, we have to look back in time. Back in 1941, Albert was in his garden pruning his roses. While working, he got a small scratch on his face, which would eventually become his worst nightmare. The scratch got infected, and the infection spread around his whole body. Abscesses formed across his face, eyes, and even lungs. Now his life was hanging by a thread, all because of an insignificant scratch. And this was not really some freak, rare case for those times. In the pre-antibiotic era, when someone got infected, doctors were essentially powerless. All they could do was wait and hope that the patient's immune system would figure it out. And the treatments they used were more harmful to human body than to the infection. Like phenol, also known as carbolic acid. While it was somewhat effective against bacteria, it was even more effective against human body, specifically white blood cells, which are responsible for body's protection. Meaning treatments like this often destroyed the body's natural defenses, allowing the bacteria to grow even faster and potentially speeding up the patient's death. Albert by this point was in critical condition. Some sources note that he was in extreme pain and had already lost an eye to the infection. So researchers from Oxford proposed to use an experimental drug on him. Since Albert and his family didn't have any better alternatives, they agreed. And it worked. Within days, Albert's condition started to improve. Just a few days ago, he was on his deathbed and now was on his way to live a normal life again. The drug was the penicillin, the world's first antibiotic. But it was an experimental drug back then, so researchers had only a small amount. And unfortunately, the supply ran out before Albert was fully treated. Even though he was almost fully recovered, the infection returned because of this. And tragically, Albert passed away shortly after. But this was the moment where humanity realized that we had found a solution. And all this happened because a man named Alexander Fleming worked in a messy laboratory. On September 3, 1928, Fleming returned to his lab from his summer vacation and started checking the petri dishes he left out. Each one had Staphylococcus bacteria growing in them, and inside one petri dish, a mold had grown, a common annoyance for bacteriologists. But when he looked closer, he noticed something weird. The bacteria colonies were looking different near the mold. Intrigued, he checked with a microscope and found out that the bacteria near the mold had become more translucent and started dissolving. Further away, other colonies were completely fine. It was the mold. It was killing the bacteria. So he continued to experiment with the mold juice and found out that it kept its effect even when he diluted it with water in 1:1000 ratio. And unlike previously used phenol, it did not harm human white blood cells. From then on, Fleming and his assistants got dedicated to making penicillin into a usable drug. But Fleming was a bacteriologist, not a chemist. So he kept on failing to extract a pure, medically usable version of the drug. Even when he published his findings, the medical community paid little attention because of how difficult it was to produce the drug. Thankfully, almost a decade later, Howard Florey and Ernst Chain at Oxford University took Fleming's idea and finally succeeded in concentrating it into the life-saving drug that would change the world. And so began the golden age of antibiotics. All of a sudden, cases like Albert's became a thing of the past. For the first time in history, diseases that had caused massive epidemics for thousands of years could now be effectively dealt with, like tuberculosis, which by the way has killed 1 in 7 people who have ever lived, or like syphilis, a disease that once slowly destroyed your mind and body over decades, now cured with a single injection. And eventually antibiotics became more accessible. In the United States, production skyrocketed from 21 billion units in 1943 to more than 6.8 trillion by 1945. By that time, the US government also removed the restriction on penicillin and everyone could afford it at their local pharmacy. As manufacturing became more efficient, the price for 100,000 units dropped from $20 in 1943 to less than 10 cents by 1949. Humanity felt invincible, but also grew complacent. Fleming himself issued a prophetic warning in 1945. He said, "The time may come when penicillin can be bought by anyone in the shops. Then there is the danger of the ignorant man who may easily underdose himself and by exposing his microbes to non-lethal quantities of the drug, make them resistant." And unfortunately, Fleming predicted exactly what would happen next. Now when we think about the responsible use of antibiotics, first we would think about individuals self-prescribing, using antibiotics without knowing the true cause of their infection, or using it for not long enough to completely eradicate bacteria. This is a problem because bacteria are incredibly adaptive. Even if very few bacteria survive the initial exposure to antibiotics, those remaining few will reproduce and pass on the ability to resist to that specific antibiotic to their offspring. And when the patient tries to use the same drug again, the bacteria simply do not care. But unexpectedly, a bigger problem we have is in livestock. Some sources estimate that around 70% of all antibiotics are used in agriculture. Since animals often live in bad conditions, it is understandable that livestock owners use medication to prevent them from getting sick. But it also can create resistant bacteria in those animals and contaminate the meat we consume. There are also hospitals filled with patients with low immune systems where heavy antibiotic use is unavoidable. We essentially have created a perfect breeding ground for nature to create its own superweapon. That's how superbugs like the CRAB or MRSA and others were created. Currently, those resistant bacteria take about 1 million lives per year. It is estimated that by 2050 that number will grow to 10 million. That is more than any other cause of death, including heart disease and cancer. We are forced to make stronger antibiotics to fight off the stronger bacteria, but it takes on average 10 to 12 years for a new drug to get approved to be usable. We are currently in an arms race with the nature. It's the human ingenuity versus the evolution. But actually, things are looking not too bad recently. Let's go back to Tom. As he is in coma and infected with the bacteria that is resistant to every single antibiotic in existence, there is practically no hope. But Tom's wife, Stephanie, an infectious disease epidemiologist, suggests an interesting idea. She suggests to treat Tom with bacteriophages. Bacteriophages are viruses that target only bacteria. They have a unique design that makes them very efficient at killing. After locating their prey, they land on them and get attached. Then they inject their genetic information, which, after reaching the bacterium's core, essentially hijacks their reproduction cycle. Now the bacterium starts making more of phages inside of it, and this continues as long as the overwhelming amount of phages burst out of their victim and move on to their next target. This is the deadliest being on the planet, causing what's estimated trillions of deaths every single second. The perfect solution to get rid of Tom's infection. Well, in theory anyways. For this to work, they needed to find a perfectly matching phage that targeted exactly what infected Tom. Stephanie and Tom's physician, Dr. Robert, contacted researchers at Texas A&M and the Naval Medical Research Center. They identified 8 phage variants that were active against Tom's specific superbug. Because the phage therapy is not a standard treatment, the hospital and the FDA provided emergency approval, and the results were almost immediate. Just 3 days later, Tom woke up from his coma. Within weeks, he was off the life support, and a few months later he was back home. This is the story of Tom Patterson. His case proved that phages might actually become the ultimate solution to all the resistant bacteria. No matter how adaptable bacteria are, they cannot adapt to the deadliest being on the planet. And actually, phages are not the only thing that are effective against the superbugs. Researchers are finding answers in unexpected places, like plant extracts from ancient recipes, the body's own defense mechanisms, even repurposed existing drugs. Given all this, the worst-case scenario of 10 million annual deaths probably will be prevented. There may come a time where we get rid of superbugs for good. After all, humanity has faced worse problems and still came out on top. But this doesn't mean that we can relax and get complacent just yet. That's how we created superbugs in the first place. The one thing we can all do as individuals is be more responsible with antibiotic use. That way we will lose fewer people until the ultimate solution is made. If you enjoyed this, you might also like this video. See you next time.